Hey everyone, I'm Yegor, I'm Kotlin project lead and I work at JetBrains. There was this nice question about, hey folks, what comes after Kotlin that folks just discussed? And I have an answer for you, because after Kotlin comes Kotlin 2.0. And yes, on May 21st, we finally released it. This release features the new K2 compiler. And you know, this project took about 6 years from our team. And now, when it's finally released, and there are only some leftovers to deal with, we have an exciting roadmap of features ahead of us. So today, my colleague Michael and I will update you on Kotlin's future from two different perspectives. I will cover some broad directions of how Kotlin will evolve and highlight some noticeable projects, while Michael will talk much more in depth about different language features that lie ahead of us. But before we dive into the roadmap, let's take a step back and look where Kotlin stands today. Kotlin is performing exceptionally well on the server side. Our data shows about 70% growth over the last 2 years of developers creating server-side applications with Spring, Ktor, and other frameworks. At the last KotlinConf, AWS shared some impressive data. In the past year, they've seen about 13 times increase in requests to AWS through their SDK for Kotlin. And at the Spring I.O., Spring shared that 27% of Spring Boot developers use Spring with Kotlin, which is also awesome. Kotlin on Android is thriving too. Right now, about 70% of the top 1,000 apps on the Play Store use Kotlin in their code. But the most important recent news is that Google now recommends Kotlin multi-platform for sharing business logic across different platforms. And this is a significant win for the overall multi-platform ecosystem. And this level of support from a major platform vendor will further boost KMP's growth that is already quite impressive. Over the last 2 years, we've seen about 3 times increase in Kotlin multi-platform user base. And I believe that this growth on multiple fronts is fueled by the fact that Kotlin was and continues to be a pragmatic language that solves real-world problems and that is really enjoyed by developers. But now, back to the roadmap. The Kotlin team is huge, and we have lots of different things going on, so even I don't know what's happening in each part of the team. So it's really impossible to cover everything in one talk, and today I will focus just on 3 areas and most important developments in each of them: tooling, Kotlin multi-platform, and ecosystem. So Kotlin was initially created as a toolable language, and our priority in the team is making sure that your tools actually help you. Our main focus here is on improving performance of IDE code completion, highlighting, navigation, and other aspects that affect your daily productivity. And to achieve it, we're working on the new IntelliJ plugin K2 mode that is built on top of the K2 compiler. And this K2 mode already shows quite great results. We see around 1.8 times improvement of code highlighting on the huge codebase of the IntelliJ Ultimate. This is especially noticeable for large files, as you can see on this scatter plot. Right now, the K2 mode is still in alpha and is going to be beta soon. In beta, we are focusing on the feature parity with the current IDE plugin to catch up on all the features that it has. But after beta, we are going to focus on even more performance improvements with the goal to bring this K2 mode as stable later this year. The best build tool is the one you're not aware of until you explicitly want to. We're working on making this vision a reality. This mostly involves lots of different continuous improvements for Maven and for Gradle, specifically with a focus on better performance and simpler configuration. But we're also exploring another way of how to design a build system that really stays out of your way. It's called Emper, the new build tool from JetBrains that is capable of configuring both Kotlin JVM and Kotlin multi-platform projects. Emper initially started as a front-end on top of Gradle, but recently it switched from Gradle to its own independent build engine under the hood. With Emper, you can set up a Kotlin JVM project by writing only one line of configuration, literally nothing else. This is enough to create and run your new Kotlin JVM project. Kotlin multi-platform is, of course, a more difficult beast, but even here you can add dependencies, declare various platforms, and specify settings with just a few lines of configurations which fit the screen. We believe that Emper will drastically decrease the entry barrier for both JVM and Kotlin multi-platform newcomers, as well as make lives of current Kotlin developers easier. Another one of my favorite projects in the tooling area is Kotlin Notebooks. Instead of describing what notebooks are, let me just play a video. Everyone faces a task of working with data at some point of time, regardless of which platform you are working on. And it's so much easier with Kotlin Notebooks. We have many plans to enhance the Kotlin Notebooks support even further, providing features like a built-in HTTP client, integration with different web frameworks, lightweight mode, and on-the-fly type generation for JSON objects. We are also adding different AI features to notebooks and simplifying results sharing via web. But that's it for the tooling area, and let's switch to another one, which is Kotlin multi-platform. Kotlin multi-platform is a technology that enables code sharing across a wide range of platforms: Android, iOS, desktop, web, and server-side. Last year, Kotlin multi-platform went stable, and it means that now you can completely safely use it in production. Though KMP is stable, there is so much more that we want to do in order to make it the most pragmatic cross-platform technology. Let's start with some core parts. We are working on a direct Kotlin to Swift export, which brings Kotlin interoperability with the iOS world on a completely new level. This is a standalone tool which is also integrated with the IDE. It takes your Kotlin sources or libraries and translates its public API into idiomatic Swift code. Right now, Kotlin to Swift Export is still a very early prototype, but what's best is that you can already play with it in Kotlin online playground, which is play.kotlinlang.org, and see which APIs it will create from your Kotlin code. We are also working on a new publication format for Kotlin libraries, which will allow you to build any target you want from any operating system. For example, it removes the need to have a Mac machine to build your library for iOS, and we think that is great. And with all modern browsers finally supporting WebAssembly, Kotlin WASM has graduated to alpha. Right now, we are focusing on the next major milestone, which is promoting it to beta. And this promotion will include lots of investments in performance and bundle size optimization, as well as providing first-class tooling support, specifically for debugging your Kotlin WASM code. Kotlin multi-platform's main superpower is that it's not a framework that boxes you in. It's a very flexible technology. And it's entirely up to you to decide to what extent you need to integrate Kotlin multi-platform in your application. You actually don't need any additional libraries, frameworks, or tools to start using it and share your code. But if you want to have more powers, then I have some updates for you. Our UI framework, Compose Multi-Platform, enables creating beautiful UIs for any of the supported platforms. We've just graduated Compose for iOS to beta at the KotlinConf, and right now we're going to work on stabilizing it. This involves improving UIKit and Swift UI interop, navigation transitions, and accessibility features. Besides the iOS part, we're also working on 2 other platforms, which are web and desktop, with tons of other exciting features to come. Besides Compose, in close collaboration with Google, we're bringing a set of Jetpack libraries, which are standard de facto of Android development, to the multi-platform world. This set of libraries include lifecycle, view model, navigation, room, paging, and many more. So we plan to continue commonizing even more Jetpack APIs. But the cornerstone of a great developer experience is tooling. Of course, you are able to build a Kotlin multi-platform application and run it from Android Studio or from IntelliJ IDEA, but we want to go even further. That's why we work on bringing you a single all-in-one tool for Kotlin multi-platform development built on the Fleet platform. Right now, it's available as a preview, so you can already try it. It's capable of many great things. I won't show each of them, just a couple. For example, it helps you with configuring your development environment by doing various pre-flight checks. And you know, configuring development environment for a multi-platform development is quite a complicated step, like literally always, and Fleet really helps with it. It also fully supports Xcode projects in Swift, provides you with cross-language refactorings and navigation, abilities to run and debug your app for any target, and drastically improves your experience with editing Compose code with features like Compose previews. We're continuing to improve this IDE based on your feedback, so we aim to make it like a perfect feature-complete tool for creating any type of Kotlin multi-platform application, so give it a try. But of course, nothing is possible without a thriving ecosystem. The Kotlin ecosystem is like really huge, so I'll do just a very quick round of updates here. Cater, the Kotlin first server-side framework, has a tightly packed roadmap, including OpenTelemetry plugins, gRPC support, managed transactions, and simplified DI. Another framework that we work on is Exposed, which is our lightweight ORM. One of the benefits of Exposed is that it provides a statically typed language which is quite similar to SQL and which allows you to easily query databases without the downsides of having raw SQL strings right in your code. But the API is not perfect yet, so we want to try and bring the syntax as close as possible to real SQL, stabilize it, and release Exposed 1.0. In the core libraries area, we're focusing on stabilizing Kotlin X datetime, Kotlin X IO, and we've also recently at KotlinConf introduced Kotlin X RPC, a Kotlin-first multi-platform RPC framework that you can already check at GitHub and try in your projects. And of course, we understand that even if we really want it, we can't provide all the libraries and frameworks by ourselves. So one of the most important areas of investments for our team is library authors experience. We've recently significantly improved Docker, which is a tool for creating documentation for libraries, both from the Gradle plugin side and from the UI and UX of the output documentation. We've released a multi-platform binary compatibility validator and great new guidelines for creating idiomatic Kotlin library APIs. We see that library creators are really happy about this stuff, so we continue to provide them with even more tools and guidance here. So this is just a quick glimpse at our product roadmap. I've skipped many important developments, such as different compiler improvements, specifically in the performance, analysis API that will enable you to write better tools over the compiler frontend, AI advancements, and more. For detailed updates, check out our public roadmap, which is Kotlin/roadmap. It will soon be updated. Right now in the Kotlin team, we're having our semi-annual planning, which is quite a mess. So after it, we'll update our public roadmap and you will see what's going on with Kotlin after 2.0. But as I said in the beginning, the most important thing that attracts developers to the Kotlin ecosystem is not tooling, not multi-platform, not the ecosystem. It is the language itself. Concise, expressive, and pragmatic. So let me introduce Michael Zarechinsky, our lead language designer, who will tell you more about Kotlin's language evolution after 2.0.
Yes, thank you, Igor. Thank you, and hello, everyone. So my name is Michael. I'm in charge of language design for Kotlin at JetBrains. And today we are going to take a look at features in Kotlin 2.0 and beyond. So we'll begin with a brief recap of past changes in Kotlin and the reasons for the K2 compiler. And then I'll highlight the main changes of 2.0. And we'll be looking at all the new exciting features that we'll be able to ship after 2.0. And I'd like to start with a short overview of Kotlin and its history, as it's hard to talk about the present and future without mentioning the past. And so the first thing that I'd like to mention is that the first version of Kotlin was actually released about 8 years ago, and a lot of things have changed since then. And considering language features alone after 2.0, it's worth mentioning such features as coroutines, multi-platform projects, functional interfaces, type aliases, and many others. And it might seem like these features have been with Kotlin since day one, but they actually were introduced gradually. And a closer look at all the changes reveals such features like trading commas, range until operator, and exhaustive when statements. And if you look even closer, we can see that over the past 8 years, the Kotlin programming language has evolved pretty significantly. And Kotlin updates has resulted in the addition of several dozen features, not mentioning bug fix updates, smart casts, and type inference improvements. So if we consider these updates, can we say that Kotlin is mostly about a language? We can, to some extent, but of course, Kotlin is a language, but not only. Like, apart from the core language, Kotlin targets several compilation environments, including JVM, Native, JS, and WASM. We also offer Kotlin scripting with its shiny Gradle Kotlin DSL. And we know that Kotlin is extremely extensively used for Android and server-side and has all the necessary technological stack, like to develop, debug, and publish applications. Of course, we have plugins for IntelliJ IDEA and Fleet, and provide a bunch of our like own Kotlin X libraries and like thousands of open source libraries from our community. And also, I think that one of the unique advantages and capabilities is for Kotlin is that it's possible to write extensions via compiler plugins and bring new framework and styles. And of course, I can get around the Compose compiler plugin that enables Jetpack Compose, a toolkit for building UI declaratively. And this is something that is really possible in Kotlin and not like and very, very hard to bring to, for example, to Java. And here's the new Kotlin compiler. And the very reasonable question is, why do we need this compiler? Is that we could achieve all of that without it? The first thing is that some of Kotlin language features and directions have appeared quite unexpectedly. And this is quite well aligns with what Fox said previously, is that we have to accept that there were a few mistakes in early design of Kotlin. And for example, the compiler wasn't ready for specific requirements. And in general, that's okay, because we can't predict the future and or know which language features will be needed in 5 or 10 years. And specifically, our multi-platform capabilities require non-trivial contracts from the compiler to unify the work across all different targets and share the common code. And now that we have vision for multi-platform projects, we want to double down on this direction, and we needed a solid foundation in our core compiler. The next issue concerns our interaction with compiler plugin and IDEs. So originally, the compiler was developed in the same repository as the plugin for IntelliJ IDEA, resulting in tight integration with our IDE and utilizing all the necessary internals from the compiler. And so this allowed us for rapid development, but came with its own costs. And like people used to ask us, where's the compiler API? And it's not that like we hid it. There were just no compiler API. There were just only a bunch of internals. And as part of our effort, we moved the plugin for IntelliJ from Kotlin monorepo to IntelliJ IDEA monorepo, and introduced an API layer to communicate with the compiler. And once again, like providing opportunities to write compiler extensions for the JVM is one thing, but offering support for multi-platform plugins is a whole different story. And of course, there's compilation time performance. You can never be truly satisfied with performance, especially with the growing lines of code to compile and extensions for Kotlin. Like we know that if you're using KPT with Kotlin or some compiler plugins, then, for example, incremental compilation doesn't know anything about the changes and have to recompile all your code altogether. And here's Kotlin 2.0. So with all the ideas and foundations in mind. And Kotlin 2.0 has just released, and the update includes more than actually 80 features across different subsystems, including build tools, incremental compilation, Kotlin backends, and so on. And one of the significant aspects of Kotlin 2.0 is its focus on performance and correctness. However, as it usually happens when you're rewriting something, you end up with a bunch of new features. But in our case, all of those features are not syntactical, as we'll see, but more about extending our existing features in Kotlin, making them more powerful and robust. And as one of the results, we don't have large breaking changes in this release. So yeah, let's take a look. So how can we describe like compiler changes in general? One of the key changes of Kotlin 2.0 is the introduction of so-called front-end intermediate representation, or FIR. So this is a transformative change that deconstructs complex language constructs into simpler, more manageable components. So this is called desugaring. In Kotlin compilation happens now way earlier than before, allowing us to have more consistent rules for analysis. Also, we introduced a phased approach to analysis process. So With this approach, it's possible to provide specific extension points for integrating into the compiler and IDE. And a key benefit here is that if you're developing a compiler plugin for Kotlin, you don't need to provide a separate IDE plugin anymore. And with the current architecture, our IDE will automatically recognize new compiler extensions and will properly highlight them and provide them like new declarations in auto-completion and find usages and so on. And last but not least, we completely rewrote our control flow engine, which is designed to offer more sophisticated analysis of code's execution path. So with this engine, the compiler can better detect unreachable code, potential bugs, and other issues that could affect the runtime behavior of applications. And this is also where most of our new features come from. But what are user visible changes? I'm going to highlight just a few of them, so let's start one by one. And first is our FIR. And one thing about Kotlin and indeed any other powerful language is their ability to compose different language constructs. And Kotlin, for example, has many operators designed to work together, although the compiler implementation might not always align with your expectations. Just to give you some intuition, let's start with this code. Here we have a simple function that increments the first element of the immutable list of longs by adding an integer literal one. Note that we are adding the first element of a list, which is long, with a literal one. So here we used a numeric conversion from an integer literal one to a long. So now let's simplify this code a bit. If we do this, if we use like plus assign operator, then the compiler will emit an error because it failed to combine operator calls and numeric conversions together. And we could meet such issues here and there from time to time, which like increases the friction when you're using a language. And here's where our intermediate representation shines, as the compiler can now desugar this code and can perform all the necessary conversions. And now how in such a simple case, we've used actually 3 operators, like set, get, and plus. Plus, we used a numeric conversion from literal one to an integer. And the case can be even more sophisticated. So, for example, if we have this class box that holds our mutable list of longs, in the function we want to increment the first element of the list again. The compiler fails to do so, but in this case for a slightly different reason, which is related to using a nullable left-hand side of a plus assign operator. And in 2.0, such expressions can be properly desugared, again, adding even more operators to the desugaring process. So again, Kotlin's power comes from its composability, and with Kotlin 2.0 we have more consistent and robust rules for operators, delegated properties, extensions, and their combinations. Now let's go back to features, and the next big thing is our new control flow engine that helps us predict code behavior, or in terms of Kotlin, it means that we'll get more smart casts. So let's see a few particular examples. So this is a very common code that we have a class cat with a single method, and in the function petAnimal we check. If our object is a cat, then we can safely invoke its method. It's pretty straightforward. We use one of the central features of Kotlin, which is called smartcast. But one missing piece here is that if we extract the nullability check to a variable, then we'll get an error because we can't call the method anymore. And the reason is that our variables don't contribute to smartcast logic. Only a few expressions did, like type checks or null checks, for example. And with the Kotlin 2.0, like now local variables can also carry the necessary data flow information and also contribute to smartcasts. So in the example above, our code will compile just fine. And speaking about composability, the feature works with all regular smart casts, including contracts. In the example, we have a class card with a property holder of a nullable string type. And our variable card with holder can produce actually two smart casts. The first smart cast is from the type check, and the second one is from the function is null or empty, which has a special contract. And they both will be applied in an appropriate blocks of code. So here, in one of the branches for when expression, we know that card should be typecasted to card, and its holder will be typecasted to non-nullable string. The next change is about smart casts inside changing closures of lambdas. So this Kotlin function index of max returns the index of the maximum value in an int array. And if the array is empty, it returns null. And the interesting part for us is in this check for null. So you see this check didn't produce any smart casts for the max I variable because the variable is captured inside the lambda. And in general, we actually don't know anything about this lambda. It could be stored anywhere and just be executed even after the for each index call. But there's one thing that we can take advantage of. This function for each index is an inline function. So it means that its body has to be inlined at a call site. It means that its lambda cannot be stored anywhere and has to be executed in place. Which means that, and for this particular behavior, we have a special mechanism in the language. So which is part of our efforts system. So starting from 2.0, the compiler treats all inline functions as having an implicit call-in-place contract, explicitly telling the compiler that such lambdas cannot be stored anywhere. And this allows us for more smart casts, including smart casts inside changing closures. And the next update is about smart casts after logical operator OR. So let's have this simple interface status that has a function signal and three sub-interfaces, OK, postponed, and declined. Previously, the compiler didn't perform any smart casts after a logical OR operator at all. So if we checked that our variable is either postponed or declined, we still couldn't invoke the function signal. And with the K2 compiler, we started to merge information from the OR operator. And now we can infer that our variable is the closest supertype of postponed or declined types, which is status. So therefore, we can invoke the function signal, which is available on this type. And again, before, only simple type checks and cast and null checks contributed to smart casts, but now we extended such expressions to include local variables and the OR operator. And there are more just bug fixes to smart cast mechanics. Some of them are just small improvements, some are like bug fixes in the language, but in general, the static analysis of the compiler has significantly improved in Kotlin 2.0. And so, speaking about what's next, we have our multi-platform with Swift export, stable klib format. We have tooling with Ampere, Gradle, libraries, compiler. So this is what Igor just presented nicely. And of course, we have language. So let's talk about language a bit more. So we've seen quite a few changes to smart casts. And also you can ask us, like, why focus on data flow framework? And the reason is that we see that describing control flow is one of the main tasks of a developer. So we are working with data more and more, and we like to provide more concise syntax to inspect data and describe conditions. And this improves readability of the code and in many cases removes layers of nesting. For example, we also see that Java has included switch expressions and pattern matching on records. And although Kotlin has included some of those features like when expressions, which is like a restricted form of pattern matching, and is at the forefront in many others with the notion of smartcasts. We should still keep improving to give our users even more powerful tools to express the control flow. And smartcasts are among the most efficient methods to enhance data-oriented features because they actually don't require additional language constructs and can be incrementally improved. But we are working on a number of other features as well. And here's the first direction where we are working to provide more and more updates. And this direction is about data recognition and deconstruction, which includes such features as guards, context-sensitive resolution, improvements for data classes, generalized ADTs, and effect system capabilities. So let's take a closer look. We'll be using this code, so I'll go through it. So this Kotlin code defines a composable function designed for use in UI. It takes a sequence of data and ID string as parameters. And within the lazy column, it finds a lazy data object matching the given ID. Then, based on the type of the selected search panel, it conditionally displays different UI elements. If the panel is a news panel and not blocked, it displays news result with the found data. You see, we repeated the search panel variable 4 times within the when expression. And this repetition suggests that this variable is central to deciding which UI component to render. However, repeating the variable multiple times could potentially make the code less concise and slightly harder to refactor, as the variable search panel was intended to use only in the when statement. And in Kotlin, one way to mitigate this aspect is to leverage so-called when with subject construction, where the subject search panel, in our case, is captured and restricted to the body of this when. So let's try doing this. If we do this, we get a compilation error that end is forbidden at this position. And the reason is that the when expression in Kotlin allows for type checking or matching against specific values only. So to fix this issue, we are going to introduce guard conditions in when. So the essence of adding guard conditions is to allow for more nuanced checks within the when expressions, without significant changes to the language syntax. So guard clauses, if in the example, allow for additional conditions to be checked along with the type check before executing the branch's code, reducing the need for nested if statements or verbose when branches. And we've already implemented this feature, so we are going to release it in beta in Kotlin 2.1. And you also might ask why did we pick if as a guard? So you can join our keep discussion. There are like a lot of hot comments about this. And one of the main reasons is that if clearly shows that it's not like end and logical end operator, so it has slightly different meaning. Plus, guard operator can be extended to more use cases in future. For example, we could use if in for loops, which we're considering to introduce later in Kotlin. But can we do better? If we take a look again at this example, you see we still have to repeat the search panel for each branch, that makes the code more verbose than necessary. And we still have to parse through redundant information. So the next little improvement will allow handling through instances of shield types or enum entries directly, without repeating the base class name when the expected type is well known. So this approach reduces the need to repeat search panel, making the code cleaner and more focused on the unique handling of each panel type. And also it's interesting that we published a keep proposal, so the describe proposal for this feature just yesterday. So you can also can come to our keep section and comment on it, whether you like it or not. And I also want to mention that this feature is also applicable to all the places where the expected type is well known. So, and one of such places is the addition of default values to parameters. So, for example, here we repeated again status a few times. And with the context-sensitive resolution, it will be possible to emit status on the right. The next thing is about JDT style smartcasts. So in future, it will be called just smartcasts. So JDT here stands only for some internal terminology, because here we have a small problem, because JDT stands for generalized algebraic data types. And in Kotlin, we don't use this term. Instead of some types and product types, we use in Kotlin data classes and field hierarchies. And this term JDT comes from functional programming languages and type theory. And in Kotlin, we are not that functional, so in future it will be just smartcast. But for this presentation, I will call it JDT style smartcast. So let's take a look at simple hierarchy. So we have a field class container, which holds a value of a generic type T. And also we have int container, which is a subclass and contains an int value initialized to 42, and string container, which is a subclass and contains a string value initialized to Kotlin. And if we have a simple function on the box that takes container as a parameter and returns its value, then of course everything is okay. But if you do the same operation for subclasses, we'll get a compilation error, which might be surprising at first sight. But let's break it down. If you take a closer look at the problem, we can see that we promised to return a value of type A, but we are actually returning either string or int, which is forbidden. And to make it even more clear, I can inline those values. And we can now probably see that this problem is actually non-trivial, because we have to somehow bind and tell the compiler that A in this particular branch can be only int or string. And this is what is called JDT style smartcasts, which means that we can use subclassing information to convince our compiler that this generic A can be either int or string after these type checks. So this topic is currently under research, and it involves some portion of type theory. So we are going to publish a paper on actual paper on a conference, but we see pretty good results, and so we are going to also to publish a bit simplified KEEP with a proposal soon. And the next thing is about data classes and improvements for data classes. So data classes are very popular feature, is very popular feature in Kotlin, but it is broken in many places. For example, and one of them is that we have name positional based destruction by default, which means that if you have a data class with parameters like name and last name, you can destructure with any names you want. And for example, you can unintentionally change the order of them, or if you add a new parameter in the middle or at the end, your behavior of, you have to update almost every place of your destructuring. So what we actually want to do is to introduce name-based destructuring, and we'll start with gradual warning, and it will take some time. So we'll start with emitting a warning that if you're using wrong names during your destructuring, then the compiler will emit a warning. And ultimately, at some point, there will be even no components at all. So we're also going to slightly reduce the amount of methods that will be generated for data classes. And yeah. So again, for this section about data recognition and deconstruction, we are going to introduce guards, which are going to be released in beta in Kotlin 2.1. Context-sensitive resolution in 2.2, improvements for smartcasts, and data class improvements as well. And I'm not going to cover about effect system capabilities today because it will take like another hour. But we are going to pick features from effect system capabilities, so our contracts, Kotlin contracts, and make them stable one by one in each release. But let's return to our original example. We still have a couple of interesting functions there, and one of them is a lazy column function. So the lazy column function is a composable function provided by the Compose UI, and it's used to display a scrollable list of items that are lazily loaded. And as many UI dedicated functions, it has a lot of parameters that carry rendering information. And such functions heavily utilize the use of parameters with default values that allow us to reduce the number of required overloads. But what if we decide to add a new parameter to such a function? In this case, we'll have to add it to a new overload to maintain backwards compatibility, because such functions are usually part of a library. And these are just a few examples where authors had to add new overloads already and to deprecate previous version of a function. So this is actually a Compose, JSPEG Compose library. And the addition of a new overload also means that we have to duplicate all the documentation for all the parameters, which we saw is a lot. So, but if we take a closer look at our function, we can actually notice that many parameters are just settings that are shared between similar UI components. So we propose a solution that follows the idea of having a class to represent the arguments. And this proposal provides a way to design APIs with a growing number of optional arguments, keeping source compatibility and also aiming to keep binary compatibility as well. And one of the outcomes is that parameters will be documented only once at your data arg class. And of course, we want to leave the door open for library authors to have full control over the representation of the arguments by skipping explicit creation of such classes at call sites. So for end users, everything will be the same, but it will be easier for library authors to evolve such API. And it was only one of the features dedicated to the area of library code evolution. So in this area, we are also working on signature management, features aiming at providing mechanisms to enforce named parameters and to check return values. And of course, we have a lot of data regarding KDoc. So, and this is an area that we are going to work on, and because previously we always considered like library authors like as a very powerful users, and we thought that well they can struggle a bit, but because they're just not that many libraries comparing to like end user applications. But nowadays we decided to make this a bit better. And to share one of the exciting features that I hope that will appear in Kotlin in future. This is about like also a library function, but not only. So let's take a look at the function class from Kotlin standard library. The function iterates over each element in the sequence, and for each element, it checks if the element matches the predicate. If an element matches, it updates the variable result to that element. This means that only the last matching element will be stored in the result by the end of the iteration. So it looks correct, but actually it's not. Because what if the predicate checks for nulls? You see, our collection can store nulls, and we can differentiate the situation when we didn't find anything from the situation when we found null. And to handle this case, we need an additional variable not found, that will be updated if we actually found the required element. And this solution also comes with the price of more complicated code and an unchecked cast at the end, which shows us that something is wrong here. And for example, in order to get rid of this additional Boolean variable, we could use some private object as a tag that will serve us as a signal that if we didn't find anything in the sequence, we could use just result. But is this approach good enough? It's definitely shorter, but in this case, we have to convince our type system by using the most generic type any. And also, we still have this unchecked cast at the end. So this code clearly shows that something is missing in our type system. And the missing type is the ability to specify union types for errors and exceptions. So the code here uses a union type for the result variable. And union types allow a variable to hold a value of one type or another. And in this case, either an element of the sequence or a special not found object. Note that in this case, the type system immediately helps us to streamline the code by putting automatic smart casts where it's needed. And this pattern, I have to mention that this pattern with unions is designed specifically to handle errors situations and distinguish between successful and error cases. So it means that there will be no union types in general, so it won't be possible to create int or string types, and it will be mostly used to declare union types in the return type or for local variables. And for int or string types, we see that this is actually a quite separate use case. So when people ask us, hey, I want to declare this type, actually they want some kind of conversion because they have some relation between int or strings. For example, or they have some relation between string or files, where you declare a path or a file. And for that case, we see a slightly different feature that can actually could fit better for those cases. So that was one of the features that is about our direction that is called increasing abstraction, which includes such features as context parameters, which were announced like a while ago and were experimental since, I think, Kotlin 1.8. Also, explicit backing fields, union types for errors, string literals and string templates, and of course, deep immutability. So we see that we still have a lot of UI activity, and we want to provide a way to conveniently update your immutable data structures and to declare them as actual immutable ones. And this is also what we want to improve with the, I hope, upcoming Valhalla project in Java, which is about bringing value types to the JVM ecosystem. And I think the last feature that I'd like to show today is about explicit backing fields. So this kind of pattern you could see everywhere, including Android. And here we have a small problem, but it's a nasty one, that we have to repeat our city 3 times. And basically they should serve as a single declaration. And we see this pattern in more than 100,000 files on GitHub. And usually it's about list to mutable list, shared flow to mutable shared flow, and live data to mutable live data. And the reason is always the same. We want to have a read-only view, which is a public one, and to give it out to our users. And internally, we want to use a mutable one. And in order to fix this, we are considering adding this feature, which is called explicit backing fields, which was an experimental in Kotlin 2.0. And we are going to move it to alpha or beta in Kotlin 2.0 by introducing an explicit field where you could say that in this container, my view model, I will be referring to this field, which is like mutable live data. And users from outside will see only a read-only view, which is live data. And that's all for today. So thank you very much for listening. I think we have 1 or 2 questions. And yep.
Thanks for talks. So if we migrate now to Kotlin 2.0, what's your IDE experience with 2.0 plugin? So should we keep 1.0 plugin still or try 2.0?
Yeah, so it will be fine to use K1 plugin because Kotlin 2.0 is backwards compatible. And we are also, it's one of the reasons why we don't add new syntactical features, because we want to reuse K1 plugin, which will highlight your code properly as it was before. So one of the downsides is that it will be hard to use like still new features of Kotlin 2.0, that those improvements around smartcasts, because the code in your IDE will be read. But it will definitely be still possible to write your code as usually as you wrote it before. So we've been using like this K1 plugin for more than a year internally, while we were like, because we started compiling our compiler with K2 maybe a year or a year and a half ago, and there were no K2 IDE at all.
Can I speak? Oh, yeah. So, the follow-up question, just to clarify, I can just migrate the compiler to K2 and still use the Kotlin 1.9, for example?
Yes.
Okay, thank you.
Thanks a lot for your talk. It's really great so far to migrate to 2. It was simply just adding 2.00 and it just works and it was faster, and so with these improvements ahead, it's awesome. Really great, really happy about it. I was wondering, one feature I'm still a bit missing, and I think there was also some discussion prior, which is nested destructuring.
Yeah.
If that is still on the roadmap, or would be curious to hear about that.
Yeah. So nested destructuring is very interesting. It's also about pattern matching. First thing is that right now we are trying to figure out the story with our destructuring, which is like, we have to accept that we have this problem with positional destructuring, and before adding even more like nested destructuring, we want to figure out the story with and introduce named based and how it will work with our, for example, list containers, which are fine to use positional destructuring, but it's definitely not fine like for data classes. And after that, yes, we are going to think about like nested destructuring and like in binding and how it works, like for example in events. So here I think that Rust nailed this story pretty well. So it has like both positional and named ones, and we are considering also some kind of this design in future of Kotlin.
Hi. My question is, would we have any way of connecting to databases using notebooks? Because sometimes...
Come again? Notebooks with?
Notebooks, the feature that you just showed, would we be able to connect to databases directly?
Oh, it's a database.
Yeah.
Igor.
That was not a beer can. Yes, one of the plans that we are exploring right now is how to properly connect expose to Kotlin notebooks, to use expose inside notebooks to make your experience connecting to different databases easier. So that's one of the directions that we explore, but you already can do it just without expose. There should be no problem that I'm aware of.
Okay, thank you.
Okay, thanks for your talk. Well, I really like that you are adding a lot of features, and also I'm using TypeScript a lot, and I see like we have to operate in like spreads. Well, I would like to have that in Kotlin, and also I'm wondering like, why don't you support unit type in general, like only for the error case?
Yeah, so that's a good question. First of all, there are some type problems because like union types and type inference don't work together nicely, because it's an undecidable problem to check if whether your type is a subtype of another if you bring union types to the type system. But the actual reason is that we see a better solution for type script cases. And in particular, again, if you have a relation between two types, for example, string and files, we see that it's better to introduce so-called defined declaration-defined conversions, where introduce a new layer of type, for example, value class, and it has like implicit constructor, which like implicitly can convert your string to files and so on. And this way, you won't have to repeat all the conversion logic every time for your functions, and it also will reduce the number of overloads. So that's, I'd say, the main reason why you don't introduce general union types.
I think that's my turn. That's me. Yeah, I just have a... Hello? Anyways. I'm wondering, so the integration with Kotlin in the JetBrains products is amazing. Anywhere else not? I'm kind of wondering if you folks have plans to kind of make language have a protocol available at some point. Something that doesn't tie yourself to JetBrains as much.
Yeah, so speaking about LSP, we are not working on it, but we are working on on so-called platform principle. So we are going to introduce this. So we actually have this better compiler API and analysis API, and now people and our community can work on LSP protocol themselves. So and actually there are a few. I think that I saw a few implementations of it. It's definitely not perfect. And also one of the problems of LSP will be is that there will be no Java integration. So your Java LSP doesn't know anything about Kotlin once. So it won't be possible to use Kotlin from Java and so on, and there will be problems to use Java from Kotlin as well. So that's because language server protocols were designed initially for dynamic languages and not for static languages who work together. And it always be a limitation for them.
Yeah, hello, thank you for the presentation. I have a question probably to Igor. So he showed an example with a new built instrument dumper. I have never heard about it. And yeah, he mentioned that it was like a front end on a Gradle, and then start using own engine. So will any Gradle plugin natively support it?
That's a great question. Probably, the answer is that probably no. But we're still thinking of whether to keep this flavor of Ampere that is... right now Ampere is has two flavors. One is built on top of Gradle, and there it is basically possible to also use Gradle plugins. Another one is built on its own build engine. There, of course, you cannot use Gradle plugins. Still, it's a very early prototype, so we're still thinking of how to build this whole interoperability with Gradle story, what plugins are really essential to bring into Ampere. So we're exploring it, I would say. So it's really early prototype. So if you have some thoughts of what specific Gradle plugins you really need, please come to us and say it. For example, one of the things that we are looking into is SQL Delight plugin, which is a very heavily used library inside multi-platform projects. So. But I'm happy that you've heard about Ampere from me for the first time and you will try it. So that's my advice for everyone.
Thank you so much to
Thank you.
the two of you. Sorry, I have to interrupt.